Hello, everyone. Bear with me. I'll be reading this little intro off my phone here. But yeah, thank you so much for joining us. This is a special colloquium, as you know. This is sponsored by CANSSI, the Canadian Statistical Sciences Institute. And so I am the PhD student representative for the SPARK program, which is a special little part of CANSSI Ontario. So the CASS seminars, the Canadian Statistics Seminars run by CANSSI Ontario, spotlight groundbreaking research in statistical sciences, I need to zoom in, both applied and theoretical from Canada and around the world. The goal of CASS seminars is for participants to engage with leading experts and deepen the knowledge of statistical research. This seminar is a collaboration between Queen's University and CANSSI Ontario, the Ontario Regional Centre of the Canadian Statistical Sciences Institute. CANSSI Ontario aims to strengthen and advance research and training in statistical sciences by developing programs that promote interdisciplinary research and enable multidisciplinary collaborations. So yes, this is Nathalie Moon from the University of Toronto. She's an assistant professor teaching stream in the Department of Statistical Sciences. And she will be giving a talk on some of the stuff that she's been working on. So I think we can take it away. I'll be the cameraman from now on. Thank you for listening. Of course, sorry.
Okay, is the microphone working? A bit. You're good?
That was quieter.
Yes. Yeah. Okay, well, let me know if anyone can't hear me. Let me just get organized here. Okay, so hello everyone, and thanks for welcoming me here at Queen's. This is a bit of a homecoming, if you will. I grew up in Kingston, and as we'll see on the next slide, I did my undergraduate studies at Queen's. So been a long time since I've been back here, but it's lovely to see familiar faces and familiar places, even though it's been a number of years. So today I'll be talking about trying to go backwards, about work I've done incorporating various implementing various strategies to enhance equitable learning and assessment in my statistics courses at the University of Toronto. And yeah, so we'll talk about various projects I've worked on over the past couple of years there. So my background, as I mentioned, I did my bachelor's in statistics here at Queen's in 2011. Then I went to the University of Waterloo for my master's and PhD in biostatistics, finished there in 2018. From there, I went to the University of Toronto. Skipped ahead. So 2 degrees at Waterloo, and then I went to the University of Toronto, where I have been teaching in the statistics department since then. So a lot has changed since then as well. So from 2018 to 2020, I was teaching in person, as you might expect. 2020, everything changed. We went online, as I'm sure you did here. I was online for a year or so, then I had a couple of mat leaves, and I've been back in person since last 2023. Time is difficult to keep track of, but I've been back in person for over a year now. As I mentioned, a lot has changed since 2020. COVID happened. During COVID, we all learned to use Zoom and various technologies. I don't think I had ever been on a Zoom call before COVID started. So that I can't imagine going back to a time before Zoom. It's changed everything. During COVID and since, there have been a lot of changes in how we handle lots of policies around the university. It was a wild time in the midst of COVID, but even since then, things have changed a lot, a number of times. And I think we all remember during the pandemic, mental health and burnout were a huge issue, both for faculty and for students, and something that I know I'm still thinking a lot about now, because the impacts have been long lasting, but in some sense, as I'll talk about today, I think some of those challenges were present before as well. We just weren't as aware of it, or at least personally, I wasn't thinking about those things in the same way as I am now, and I can't go back to not thinking about them. So it's fundamentally changed how I approach everything I do. And of course, during COVID, everything went online. So all of our teaching, all of our assessments, for good or for bad, it was fully online. Then things got better and everything sort of returned to campus. Business as usual, agree or disagree, but more or less things went back to so-called normal. And then LLMs came along and changed things once again. All of these wonderful assessments that we developed, projects, things for students to work on at home, do they make sense anymore? I don't know. Like, what do we do in this new world where LLMs are increasingly present and increasingly capable? And so for that reason, so we pivot, we all went online for the pandemic, come back in person, but keep some online elements. Now with LLMs, do we just drop all the online stuff we developed? Do we go straight back to midterm exam, nothing else? I don't have all the answers here, but very much looking forward to ideas from anyone that has them. These are big questions. Also, since 2020, I've had 2 kids. So personally, my life is wildly different, and it makes it difficult even for me to conceive of just everything is different. So sometimes it's difficult to isolate why does it feel different? Well, because of everything. So that's where we're at now. And this massive shift has been very interesting for me to sort of reconsider everything that I do in this completely different context. And the distance between being in person in 2019 and then away from the physical classroom for 4 years, which is extremely unusual in a career to be out of the classroom for that long, just really changed my perspective on a lot of things. Okay, so coming out of the pandemic, back into the classrooms when 2022, 23, I'm sure you saw these kinds of headlines. Issues with the healthcare system during the pandemic. The healthcare system was already in crisis, but that became more apparent over the past couple of years. And I know in Kingston, that's a massive issue as well. Lots of students and people don't even have family doctors. So asking them to produce doctor's notes every time they're sick is simply not possible for many of them. And even if it is possible, it's overburdening a healthcare system that's already struggling to keep up. So pre-pandemic, I, like many people, ask for doctor's notes, and now I can't. So instead, I have a declaration of illness or personal emergency form, and I ask students to self-declare when they're sick or can't be present. And I don't ask any questions. I don't need to know why they're not there, and I leave it at that. The reality is, like it or not, students can pay for a doctor's note. There are clinics at the University of Toronto, close to campus, where you can pay $20 and get a doctor's note, whether you're sick or not. So let's not kid ourselves into thinking that these meant anything in the first place. And if you're really sick, don't go bother a doctor about it. Another strategy I've used is this best X of Y policy. This is nothing new. I remember that from my first year calculus course here at Queen's. 12 weekly assignments, only the best 10 counted. I had moved away from that in my first couple of years of teaching because every assignment was important. They need to do all of them. But I'm back to doing that now because, again, people miss classes for lots of reasons. And this is a strategy to make it manageable for me to handle and kind for them to manage their lives as well. I automatically apply this to everyone, so they don't need to tell me in advance if they're going to miss anything. I also acknowledge that just because you require people to submit everything and you dock marks if they don't, doesn't mean they do all of them. It just means that you're penalizing them when they don't. So that doesn't mean that more learning happens. You're just reinforcing inequities potentially by taking marks away from those that are already struggling for other reasons. And obviously it's easier administratively because you're not dealing with individual requests and exceptions. You're just applying this across the board to everyone. Ultimately, my philosophy in these regards is I want to trust students to do what's best for them. They're not only in my class, they've got other parts of their lives. It's complicated. When we're sick, we can stay home, take a sick day. And to some extent, I want to grant them that privilege as well. Another thing that came up a lot during the pandemic, this idea of burnout, mental health, that was an issue during the pandemic and coming out of it as well. Lots of headlines around that. And that's something I want to consider in my classroom as well. So one thing I've started doing for the past couple of years is giving automatic grace periods. This sounds scary, And this is not all, I don't do this for all of my assessments, but for some assignments, I build in a grace period. So there's the deadline and there's like the second deadline, where if they submit by the second deadline, no penalty, no, they don't need to tell me, they can just have that extra time, no questions asked. And it just gives them a little bit more flexibility to manage their time and their other responsibilities. And that has been very effective. On the note of late penalties, I don't do late penalties. I don't deduct marks for late submissions. If I accept the submission, I grade it without penalty. If I don't accept the submission because it is too late, then it's simply not accepted and not graded. If me or my TAs are going to go through the effort of grading it, it will be graded on its merits, not with no penalty. The idea here, and this is something again in the vein of equitable grading, I want the grade to reflect students' mastery of the material, not their behaviors, like their time management skills. I'm not saying time management isn't important, of course it is. But a course grade should be about how much they've mastered the material. And when you have late penalties, you're sort of conflating the two in a way that can be problematic. So just something to think about. Recording lectures. So online, it was very easy to record lectures if you were teaching a class on Zoom. But even during the pandemic, there were lots of conversations around whether or not we should post those recordings. And certainly that has continued since then. Students have certainly developed an appetite for having recorded lectures, and choosing not to post them, you're guaranteed to get questions from students. Why aren't you posting them? Please post them. But it remains a question, and people are divided on this issue. Now, for myself, the way I've reasoned through it, to post or not to post. We can post slides, we can not post slides. We can post recordings or not post recordings. If we post the slides and the recording, then we are supporting the students who can't come to class for whatever reason, which we don't need to know about. But the natural concern is that students just won't come if we post them. Fair concern. If we don't post the slides, then we're in effect trying to make them come to class. That's the rationale for not posting the slides and the recordings. You think that if you do post them, they won't come and you want them to come. So that's why you're considering not making those available. At the same time, you are penalizing the students who are missing class for valid reasons. You can't separate those two. I mean, that's just the reality, the flip side of that. So my view is that students should come to class because they feel it's useful. If class is not useful and they choose not to come, then in some sense, I can't blame them. They're deciding how to use their time. So if I want students to come to my class, then it's my job to make it useful and to convince them that it's useful. And again, them showing up and not paying attention is not helping anyone. It makes it, well, less fun for me, and it's a waste of time for them. So that doesn't feel like a win to me. Either way, but certain, so I'm on the side of posting recordings where it makes sense, not for seminar courses or discussion-based courses, but for more traditional courses, I do post materials. And I also try to create opportunities for engagement outside of the classroom. Again, because even when I do post materials, I'm trying to make my classes useful and engaging. I do post materials. If I think my class is useful, then it means that missing class, students are missing something that would be useful to them, I think. So by creating opportunities to engage and demonstrate that engagement asynchronously, I'm trying to give the students who have to miss class for a valid reason a way to engage in those ways in some sense. So some ways to do that, I've had weekly low stakes reflections where they can watch the recording or attend class and write a brief reflection about what they've learned and what they found interesting or challenging. Class worksheets that's demonstrating that they worked through the problems that we did in class, whether they do it in class with me or whether they do it by watching a recording afterwards. Either way, I'm happy with that. So just summarizing what we've, the simple or if you will, smaller changes that I've made over the past couple of years. I used to require doctor's notes. Now I don't. I have a form, an MS form, where students can record that. And that's all there is to it. I used to have strict due dates across the board, and now I have flexible deadlines or best X of Y, depending. And again, when I say flexible deadlines, it depends for what. Once I post solutions, of course, I don't accept submissions after that time, so it depends on the task. I used to not record lectures, and now I do. And another one, I sort of alluded to this on the last slide. Previously, I didn't really know if students were, how or whether students were engaging with the material in class or between classes. And now I try to incorporate various strategies to do that more through reflections, worksheets, and also use social annotation platforms like Hypothesis or Perusal, or I've used Perusal, but Hypothesis is another option that I won't be talking about today, but happy to chat more about later. So as I've made all of these changes in my teaching practices over the past few years, over the past year, some of the influences that informed my thinking, I'll just mention them here more as a reference for all of you if you're interested in looking more at what led me to make these changes. So the first is this idea of the 4 pillars of alternative grading, which I'll talk more about later in the talk. And I got this from this podcast called the Grading Podcast, which sounds really dull, but it's actually quite interesting. And it talks about a lot of the ideas I'll talk about in the next part of the talk. This idea of equitable grading practices that I first learned about through an AQ course on excellence in teaching, and is from a book by Joe Feldman as well. So a great reference also. And then more general thinking and learning about the science of learning, how we learn most effectively. There's lots of references here, but this is one book that I've looked at. And The Pedagogy of Kindness is a small book. It came out last year, I believe. It's fantastic, and it really resonated a lot with me. So if anything of what I talk about resonates with you, then that might be a book you find interesting as well. So the elephant in the room. I alluded to this earlier at the beginning of the talk, but all the changes I've talked about so far, they feel really good to implement. It feels like I'm doing the right thing for my students and for myself. Great, we're in a great place. And then LLMs come and we have to question everything. And what we're doing working? Is what our students are submitting their work? Are they learning? How do we know if they're learning? How do we know if they've mastered anything? I don't have all the answers, but this is what we're all forced to deal with in our classrooms because, like it or not, students are using LLMs, students are using Gen AI. They may tell us, they may not tell us, but they are using them a lot. So what does that mean for us in our courses? Well, in the context of, let me just look at the time. In the context of statistics courses, I've tried to categorize, if you will, the kinds of things we teach in statistics, the kinds of things our students do in our courses in 4 categories. 1, foundational skills. So computing probabilities, describing data like means, medians, all of that. I would put statistical programming in this as well, probably much less of a focus when I was an undergrad, but now I would say that's pretty foundational. They need to know how to use R or Python or something like that to manipulate data. They can't really get too far in statistics without this. So, these kinds of operations are pretty fundamental to what we do. Then there's more analytical pieces. So learning about different types of modeling, how to do model selection, including variable selection, residual analysis, everything that comes with it. Inference and hypothesis testing. That's not computation. That's sort of the next level. It's related, but not the same as foundational skills. Then we've got communication practices. So students should be able to speak about what they're doing to various audiences and write about what they're doing, explain their work. And finally, theoretical foundation, so proofs, derivations, that is also an important part of statistical education. you could argue, more or less important for different people, depending on what their paths are, but it is part of what you do in a statistics degree. Now, I won't talk too much about the theoretical foundations because the courses I've taught in the last couple of years don't really touch on proofs and derivation a little bit, but for the rest of this talk, I'm going to focus on the first three categories. So among this sort of list, which I don't claim to be exhaustive, but this list of skills and competencies, which of them should students develop in their stats degrees? And this is a pretty basic question, and I would argue that with the advent of LLMs, it's a question we have to ask ourselves again, because the answer might be different now than it was 5 years ago. It might be, and it might be different again in 5 years, because we don't know where these technologies are going. So I don't have an answer to that, but it is something we need to ask ourselves. And the first thing, according to who? So which of these skills should student learn? What do we think? What do employers think? And what do students themselves think? I don't have the answers, but these are questions that we have to ask ourselves. And also, why do each of these groups think that these particular skills are important for students to learn? Is it because they're important, whatever important means? Is it because they're useful to a future job, for example, or useful to learn more advanced topics or skills in future courses or in graduate school? Or is it because they're part of the learning process? So maybe they're not that important in and of themselves, and you'll never use them in a real job, but it's still, someone feels, they're still important to learn to gain some deeper understanding. Like arithmetic. I would argue, I've got 2 little kids, I want them to learn to do arithmetic. They will not, they can use a calculator eventually. They won't need to do that on a daily basis in their future job, but they still need to learn it now. And it is important for them to learn it now, not because, addition and multiplication are inherently useful in their future, but because it's a skill that will allow them to build up to more complicated things down the road. So lots of questions on this slide, and unfortunately, I don't have all the answers, and so I won't be covering the answers here, but just food for thought as we continue. So let's take sort of a step out of what I've done and look at what students think. So this is data I collected last year, so a year ago, and in the landscape of LLMs and Gen AI, that's a very long time. So I can imagine it's whatever I show you today, it's even more now, a year later. So this is data I collected in my large first year course. I have over 500 students per semester, and most of them did consent to share their results, which is great. I had 2 surveys, one at the beginning of the term, one at the end. And there were several questions in this, several research questions in this project, but the 2 that are relevant to this talk are given here. So how do students use Gen AI, and how do they think their peers are using it? So again, you can imagine how this question answered last year might be different from now. And how do they think that using Gen AI will impact their learning in their statistics courses? So this is the first comparison. So this is looking at how familiar students were with Gen AI, self-reported, of course, at the beginning and at the end of the semester. I suspect it would be way more in the agree, strongly agree, agree, strongly agree columns now. But even over the course of the winter semester last year, it did move towards the more familiar levels, which does not surprise me at all. There's a lot going on here. So this was a question. They could select all that apply. In what ways do you, the students, use generative AI in your day-to-day life? So for these top couple of sections at the top, over 50% of students reported using Gen AI for those purposes. Okay, so asking questions, asking general knowledge questions, just playing around with it for fun. Okay. And I'm going to exclude other and never used it, but writing code, solving homework, writing essays or paragraphs, reported prevalence much lower, around 30% or less. And the blue bars are for the end of the course and the red bars are for the beginning of the course. Okay, so that was how do you use Gen AI? Then I asked students, oh, you can't see the title, but in what way do you think your classmates, your peers use Gen AI? And in particular, this section at the bottom was wildly different. So again, less than 30% self-reported, but over 50% assume that of their classmates. So I don't know what the truth is, except I suspect both of these are higher now. That's my guess. I don't know the reason for this discrepancy. One guess is social desirability bias, where when asked a question, you're going to want to, when you're asked about yourself, maybe you want to say the right answer. You don't want to admit that you're using Gen AI to solve your homework problems, concerned that it might not be allowed, even though these were anonymous surveys. Actually, no, I guess I do have their names, but I wasn't looking at that. Yeah, so I don't have an answer to this, but I do think it's interesting. And I suspect that the truth is probably closer to the second bar plot than the first. And again, I suspect the proportions are way higher now than they were even a year ago, based on conversations I've had with students. I don't expect you to read all of this here, but the slides will be shared afterwards, so you can look at it more closely then. This is a question where I asked students, how do you think using Gen AI is impacting your learning in these different categories? So I've got writing skills, coding skills, development of communication skills, problem solving skills, and so on. And it's a bit of a mixed bag. I won't go through all of it. We've got neutral in the middle. This side is positive. So the left side is, I think it's helping me. And the right side is, I think it's not helping me. I don't exactly know what to make of these results. But I do have some sort of follow-up questions around these results. First of all, are students equipped to even know if using these tools is helping them learn? It helps them, it makes them feel like they're learning because they type something in and they get an answer and it looks good and it's better than what they could have done on their own, maybe. So they feel like they're learning, but are they actually learning? I don't know. And I don't think they know either. So I'm not sure exactly what to make of those results on the previous slide. I need to think about that more. But the reality is they are using them. Whether it's helping them or harming them, whether they think it's helping or think it's not helping, they are using them. That's a reality. So there's probably more than two approaches, but two approaches one can take in the face of this reality is one, we can try to use generative AI to leverage these technologies to help students develop the necessary skills once we've decided what those are. Or we can try to design learning activities and assessments that motivate students to learn the things themselves without using AI. Hopefully, this is so you can sort of lean into AI, or you can try to convince them in some way that that it is important for them to be able to do this without these tools. So in the rest of this talk, I'm going to focus more on the second approach, although I'm certainly interested if others have ideas on how to use, how to try to use AI to help students learn better. So another important question, why are students using LLMs? And I, again, don't have the answer, but I think part of the answer is that they're busy and they feel like they don't have a choice because they don't have time to do it themselves. And I think this is a shortcut to getting the answer faster. They might be very anxious about not wanting to lose marks, and they think that using these tools will help them not lose marks. And that's even though they might realize it's not as good for their learning, they don't want to risk losing marks and having that impact them down the road. Also, if they don't think the task is important and they can use a shortcut to get to the answer, I can understand the temptation of using these tools. And there's probably many more reasons that I didn't. So my real question, one of my big questions, is how do we foster student learning when we know they're using LLMs? So there are certain tasks that we know if we ask them to calculate a probability at home on an assignment, there's a very high likelihood that many of them will just plug that into an LLM, get an answer. And if all you're looking at is the answer, what did you achieve? Not much, really. They can produce the answer. You can't tell how they did it. There's a good chance they did absolutely no learning. And we're not really anywhere. We didn't make progress. So one strategy I'm trying to take is to try and address these root causes. So if they're feeling anxious due to time pressure, let's give them more time or have flexible deadlines and reduce the pressure in that sense. If they're anxious about not losing marks, can I implement some sort of feedback and resubmit mechanism so that it's okay if they don't get it right the first time? They can just try again. So trying to reduce or eliminate that stressor. If they feel like the task isn't important, isn't useful, and that's why they're using LLMs, then let's transform our tasks to make them more authentic so that that isn't such an issue. So that's what I want to try to do. Which brings me back to something I mentioned at the beginning from that grading podcast, these principles of alternative grading, which when I came across with them really resonated with me, especially in this new LLM Gen AI context where we want students to learn themselves. We want to be able to tell how do we know that students have learned? So this approach resonated with me in terms of maybe how to achieve that. So first, we should have clearly defined standards. So we should know what we want students to do, and they should know as well. Seems pretty straightforward. We should give helpful, actionable feedback so that they know what they can do to improve. Again, this seems pretty reasonable. The mark should be an indicator of progress. This one, basically the mark should reflect how close they are to achieving the target. And the fourth one, this idea that students can revise and resubmit as many times, we can, talk about what that means, as they need without penalty until they achieve the outcome. I don't actually necessarily mean unlimited times. There can be some limits, but in traditional statistics courses, I suspect most of us had the experience of you can submit once and that's it. So anything more than one is a step towards this reducing this stressor. So that's what I'm going to talk more about in the rest of this talk. So my context for the first example that I'm going to be talking about, so for the first strategy, concrete strategy, I'm teaching over 500 students per term in a large introductory statistics course. We have a large team of TAs, but we still have limited capacity to specifically give feedback on our coding assignments. 500 students, we have weekly assignments. We can't look at the code, the detailed code, line by line for everyone. So we do have weekly problem sets in R, and we do post solutions. The students have a mixed bag of backgrounds. Some have taken a lot of computer science, others have not. So some students are way more comfortable than others at learning independently. Others don't even know where to start. So for teaching these students R, in terms of my wish list for giving them, for them developing their R skills, is I want to give them many opportunities to practice in R. I want to give them feedback. I want them to have an opportunity to try again if they don't get it the first time. I don't want to penalize them for trying multiple times. And all of this, remember, with over 500 students per semester. And in the course, we're also teaching them statistical communication and statistical reasoning. So this is only part of the course. So that's what I want. So my solution for this has been to use the Marcus platform. Marcus is a platform, I guess, a website developed by a team at the University of Toronto, developed in-house. And essentially, I know some of you may use CrownMark here. It's sort of like CrownMark in that it's an online grading and submission platform. So students submit their work there, and then we can do you can do grading like in CrownMark, or you can do this programmatic automated feedback thing, which is what I'll be talking about today. It supports R and Python. It is open source. I asked David Liu from the University of Toronto who runs this, and there are opportunities for it to be used elsewhere. So if anyone's interested, let me know and I can put you in touch with him to have those conversations. So what do I mean by automated feedback? I don't mean AI in this context, although they may be working on building that in, but I do not mean AI here. Really, I'm talking about unit tests, comparing values in the student's submission and in my solutions. So examples of the kinds of things we can check for the value of a variable, for the data type of an R object, the length of a vector, or the dimensions of a matrix or data frame. This year, I implemented some tests looking at features of a plot, so we can check if they're using the right variables on the X and Y axis. This is only if you use ggplot, where there's sort of information on the structure of the plot that we can extract and check. Also features of a model, so you can check if the student fit the right model by looking at R² or degrees of freedom or whatever features you want to compare. But they're unit tests looking at equality of something. So I'll use these terms interchangeably: automated feedback, automated grading, automated tests. I'm all getting at the same thing here. The reason I like using them in this course is this feedback, right? They get feedback of whether or not what they did is correct or not correct. And okay, so this is the workflow. The workflow for my students in my course currently using Marcus. So they work on the problems. They run tests on Marcus, so they can upload their work, and they can do this as many times as they want. No issue until the deadline. If the tests pass, that's wonderful. Keep going to the next question and run the test again and just keep iterating. If you run the tests and they don't pass, then you can use the feedback that you got, the feedback meaning which tests failed, to go see if you can, what was wrong. So maybe you can just figure it out yourself. Oh, this question was wrong, let me fix it. And so if that's the case, you would fix it and run the tests again, and hopefully they pass this time. If you don't know how to fix it yourself, then you can go ask for help. We have a Piazza forum where students can ask questions, or they can come to office hours and they can be more specific about where they went wrong instead of just coming to you and saying, I don't understand anything, which is not a very useful question to get in office hours. And of course, then they can fix it, run the tests on Marcus, pass them, and move on that way. So this is a cycle. This feedback cycle would simply not be possible without a tool like Marcus in my class, especially in such a large class. So previously, before I was using Marcus, this is what I think the student workflow would have been. They work on the problem set, and then they ask themselves, is what I did correct? If they think so, then they submit it and they hope for the best. If they don't think it's correct, then they might ask for help, but they might not even know exactly where to ask for help. They don't know which part is wrong, just maybe it's wrong, try to get help. And then they would submit and hope for the best. And then they get a grade. We post solutions. They may or may not look at the solutions, so they may or may not ever find out if they were right or not. And it's sort of, they move on, and the feedback loop is not closed. So this, I would argue, is less effective in terms of learning. So what I've done on this project to date, so I've worked with an RA to help develop an R package. R Marcus is an open source package. It's on GitHub to make it easier for, well, me and others who want to use Marcus for this kind of thing to write unit tests. I don't know how many of you have written unit tests in R. There's a, oh, I can plug it in really good. Okay, yeah. It can be sort of messy, especially when you're getting into the plotting, like the ggplot, looking at the structure behind, or if you're looking at doing comparisons for complex model objects. So basically the package is wrapper functions that make it easier for an instructor, me or others, to implement these tests on the fly during term when we're busy with a million other things. And you want the test, but you don't really want to spend a lot more time than you already are to get them. Oh, are you kidding me? Oh, wait. No, we're good. No, we're good. Okay. Oh, yeah. So I first piloted the use of this new R package last winter, so winter 2024. And this past fall, we expanded to 2 additional courses, and I'm using it again this year. So typical use cases in my big class, weekly R problem sets, and the grade for the students is the proportion of tests they pass. Previously, it was essentially pass-fail. Now, if they pass all the tests, they get 100, and if they don't, then they get some fraction of that. One of my colleagues used it in a different way. She was teaching a 3rd-year linear regression class, and it was flipped. So she had videos that students watched before class, and then they came to class, and there were some, so prior to using Marcus, it was flipped as well, and she had worksheets for them to work through regression problems, many of them using R in class. And they would work on them, and she would be there, and TAs would be there to help them. So she implemented Marcus so that in class, while they're working on these worksheets, they can check if their work is correct or not. And if it's not correct, then they can ask for help in a more focused way. And essentially, they can know if they're on the right track or not, versus having to wait to see the solutions. And she found that to be quite effective. In fact, this term, she's teaching another class and not using Marcus. And she's found that interaction in that class has been less effective. There could be other reasons, but one of the differences is that Marcus is not being used. So I think the students like having a way to know if what they're doing is correct. So challenges with automated testing, because it's not all rosy, of course. It is an extra thing to do. And in particular, one of the things I found most challenging, although I'm still a fan, certainly, is that for a lot of the, not so much for calculating probabilities, but when you're working with data cleaning or using R to calculate various things, there can be multiple ways, there usually are multiple ways to get at the same answer. And those differences can be, well, they are different from a programming perspective. They are not equal objects. But, you know, we can have rounding errors. We can have like a 1-by-1 table that is basically a number. You and I can look at it and say, yes, that's a number, but it's not the same as a regular old number. Or you can have like, I don't know if I listed it here. If you have like the rows or the columns in a different order, we don't care from a statistical perspective, but it's a different R object. It's not the same. You specify your model differently, that might not matter. Another example actually is whether a number is coded or saved as an integer versus a double. I don't care, you don't care. We know it's the same thing, but if you don't set up your unit test properly, the test will fail for non-statistical reasons. So that's another reason why having these packages, the package with the custom functions, we can try to be more thoughtful in how we set that up to try and minimize those kinds of issues. But it is something you need to be mindful of when setting up these tests, no question, because students get very frustrated if they fail a test for something they shouldn't. And really the reason for all of this is that in statistics, R, or any programming language, is a tool. The exact implementation is usually not a focus. We're using it as a tool to achieve some result. And if you get at that result in different ways, that shouldn't matter in a statistics course. And so unit tests can be used, but we need to use them in a careful and thoughtful way. So even with these challenges, I feel that for my large classes especially, it's an incredibly useful, powerful tool. So I will keep using it and keep working on this package to expand the set of tests we can do. But there's no question that this doesn't work for all kinds of learning, all kinds of assessments. It's really only suited to questions where there's a specific answer you can compare. Anything open-ended, it just won't work. So coming back to this, this breakdown, we're now, I think I have colors here, but they're not showing. That's okay. So now we're going to focus on the 2 middle sections, analytical competencies and communication practices, which I argue are more open-ended kind of tasks, not well suited to automated feedback processes. So my process there, and I realize I'm calling these feedback loops, and that is, well, not a loop, but we'll see loops later. But for these kinds of open-ended tasks, my approach is to have this revise and resubmit mechanism. So For example, having students submit a draft, get feedback from somewhere, from a human, and then submit a revised version in response to that feedback. And depending on the course and the time you've got and resources, you can have multiple iterations of this feedback, revise and resubmit, as many as time allows and resources allow. My principles in thinking about this, coming back to the idea of the pillars of alternative grading, is that students shouldn't be penalized, or I prefer not to penalize students for a bad draft. I only want to assess them on the quality of their final submission. And I say this now, I have in the past graded students on the quality of their draft. And I after learning about this alternative grading approach, that doesn't sit as well with me as it once did. So now starting this year, I've implemented this not no penalty draft, but drafts that aren't graded on mastery and proficiency. And that feels really good to me so far across 2 different classes. So I'll tell you more about those 2 classes here. And I think that's the direction I want to keep going in the future. So what did this look like? So previously I spoke about a large first year course. And I'll tell you about that a little bit later. But first we'll talk about a smaller seminar course, 4th year seminar course that I taught. It's a course for applied statistics students. And I have 28 students this year in that course. So the process, this course is structured around, it's a full year course, structured around a consulting project where students work in groups of 3 on a consulting project with a partner from elsewhere in the university, from different departments. So they're in the middle of this process now as we speak. Their final version is due a week from today. But a few weeks ago, they submitted a draft of their report to their peers for feedback. They were then asked to give, random assignment, anonymous random assignment, and they had to give feedback to 2 of their peers on different projects, different topics. They then received the feedback from their peers and resubmit a second draft for feedback from their TA. When did they get their feedback from their TA? I think they're going to get that soon. I think today, maybe. I forget. But they're going to get so I gave the TAs about a week to grade their, or to give feedback. They're going to get the feedback, review it, and they have about a week to resubmit their final version. And for this 4th year course, I am requiring them to submit a feedback response letter. So that's sort of like the letter you would submit with a paper when you get a revise and resubmit for an academic paper, where they have to comment on how they addressed various pieces of feedback. I think I make them do it for 3 pieces of feedback, not for everything. And also they have an opportunity to comment if they chose not to implement a suggestion, they can explain why. So we're in the middle of that. Actually, we followed this structure in the fall. It worked really well. We're doing it again for their second project in the course. So what does this look like? Well, for the draft feedback, they get credit for submitting their draft, and they get credit for giving feedback to their peers. The peers' feedback doesn't impact the student. There's a policy at the University of Toronto that students can't grade each other's work. They can give feedback, but it can't go into the grade. And I'm using Peer Scholar for that. It's an online platform, but there are also options for peer feedback in Canvas and other platforms, I'm sure. Then for the draft, the second draft that they submit to their TAs, I give the TAs a checklist. So they go through the checklist and say, did the student have a title? They have an abstract? Do they state the research question in the introduction? So a basic checklist where they're looking for, did you do this thing or did you not? And they also give detailed feedback, personalized feedback. But the checklist in and of itself is a form of feedback as well, but it's not graded on quality. If you have a title, you will get the check mark for title, even if it's a terrible title, but it'll come with a comment saying, improve your title in these ways for the final submission. The final submission is graded in a more traditional way using a more detailed rubric looking at proficiency. So that's my small 4th year class with 28 students. I'm also teaching that 500 student class. And in the past, we didn't have this kind of cycle. Students have always done a project in that class, but I didn't think I had time to build in a feedback loop. but I decided to try this term anyways, which is a little bit crazy, but we're in the middle of it now, and I think I'm excited to see how it goes. I guess I'll have to wait another week to see fully how it goes, but I think it's good. So for this project, students submitted a draft for TA feedback last Sunday. And then, oh, I think I skipped. Okay. No, so we're good. So they submitted their draft for TA feedback, then the TAs reviewed. This is a flow chart of what the students do. So in that arrow, of course, the TAs are reviewing the students' work and giving feedback. So they did that earlier this week. Last night, we returned the TA feedback to the students, and now the students are revising the TA feedback to improve their submission for the project that's due on Thursday and this coming Thursday, and they're presenting their work at a poster fair on Friday. At the poster fair, they will circulate, and in addition to presenting their own poster, they will visit at least 2 other groups, and they will then think about what they could have done differently if they could do the project again, which they can't. And they will submit a reflection on that, on their experience with the project, and after seeing other people's projects, what they would have done differently. So the peer feedback is like after instead of before, which is just because of the nature of this course. That's just the way we're doing it, but it still is an opportunity for reflection and next steps. And these are first-year students, so they'll have loads of opportunities to do projects with us again over their degree. So in this class, they got their draft for TA feedback, and similar to my other class, checklist and the feedback is really the main benefit to students. And then the final submission is going to be graded on proficiency and quality. So they're working on that right now. And then the personal reflection they submit at the end, and that's, well, it's essentially a completion score, but the idea is to get them to close the circle and think back on what they could have done different compared to, based on what they've learned from their peers. So these feedback loops, talked about 2 types of feedback loops, the automated feedback loops for like programming assignments, and these more draft, revise, resubmit, maybe another draft, and eventually final submission cycles with human feedback. These 2 types of feedback loops, I think, are very effective in reinforcing student learning, and in particular, the latter type with the one I just talked about, the human feedback. The conversations in the feedback meetings, like the draft feedback meetings, have been fantastic. I was just in such a meeting on Tuesday, and it was the best TA grading meeting, feedback meeting that I'd been in a long time. There's no conversation around, is this a good or an excellent? Is this like, no, it's just everyone's there for the same purpose of saying, okay, this is what they did. What can they do better? You're not thinking about grades. You're not talking about that. All the feedback is constructive, and everyone sort of wants the same thing, which is for students to do better in their next submission next week. We'll see if that works, but I'm very hopeful that the quality of the final submissions next week will be better than it was in the past. What I found incredibly frustrating in the past, grading their final projects, is when students, clearly you could tell that they worked hard, but they missed the mark. They didn't quite work in the right direction. And it's difficult. You feel bad docking marks when they maybe just didn't understand what they were supposed to do. So this draft feedback gives us a chance to course correct before it matters, because it's no hard feelings at this point if they didn't quite get something. So it felt really good, and I think the TAs really appreciated it. We did it all together in one room, and I hope that will actually make it easier to grade the final version. So I guess that's the part that remains to be seen. In my smaller course, it did work that way, but it was much smaller, so it's a little bit of a different vibe. But I'm very happy with how Tuesday's feedback meeting went. Now, of course, there are challenges still with this kind of feedback loop. When you've got limited time in the semester, adding in each time you add a draft, revise, resubmit, draft, revise, resubmit, you need to work backwards from whenever the final needs to be submitted, and that can be a challenge. So my strategy, well, one strategy is peer feedback. You can do that loop a little bit more quickly. And also the TA feedback session I held earlier this week, they submitted on Sunday. We met with the TAs on Tuesday. We returned the feedback on Thursday. The idea was everyone come together. We're going to do the feedback in, 2-3 hours, then you're done. None of this like waiting for people to do it. You have to give them a week. And that just didn't make sense for this course. So this worked really well. Another limitation is TA time, depending on the size of the class. Each time you add an iteration of feedback, that takes more time. But again, peer feedback is a really powerful strategy. And there are benefits for students to seeing their peers work anyways. So it sort of works on both sides. And also for my big class, it is a group project. So that reduces the number of projects to like 150, which is a lot more manageable than 600. And using a checklist makes the feedback a lot more streamlined than a detailed rubric. So final takeaways, a lot has changed in everything that we do as statistics instructors in the past 5 years. But I feel that even with small tweaks to what we're doing, we can make a really big difference in the student experience and in our own experience as educators. And well, we just have to keep in mind through everything that we do that students are using these tools, and we have to think of how we can add value and convince them that what we're doing is important. And coming back to the idea of feedback, I think that when students see that we are giving them feedback on their work and giving them a chance to improve on that my hope is will motivate them to actually try to do it themselves and make use of this opportunity in a way that just a single submission with no back and forth may not achieve in the same way. So that's my hope. I don't have all the answers, but that's what I'm working on right now, and that's what I'm hoping will be one way to address the challenging times we find ourselves in. But ultimately, I think the conversation needs to continue, and I look forward to doing that afterwards.
So I think we went a little bit over that. No, it's okay. This clock is small. I forgot to tell you. Hello, everyone. So we're going to use this mic to do a little Q&A session if there's some feedback there. I'm also going to. Right. Okay.
Stand far away.
I'm also going to unmute my computer so that we can hear CANSSI if we need to. Hello, CANSSI. All right. Does anyone have any questions about Dr. Moon's presentation? Yes.
I have a quick question. You talk about student using LLM. You're talking about the student using the large language model. I wonder whether you ever consider using large language model in your teaching, or either assessment or deliver a lecture or anything.
I haven't used it to deliver a lecture, and I mean, I've heard of people doing that, and I don't know that it's super well received by anyone, including the university. So I'm not going to do that. I have played around with it myself. Certainly, it can be very useful to get ideas for various things. And I think it is important that we play around with these tools to understand what they can and can't do, which keeps changing. So even if you think you know what they can do, wait a month or less, and it can completely change. The most direct way that I've used it in my classrooms, which I think was very successful actually, in the consulting class, before my students' first consulting meeting with their partners, I had them I wrote a prompt for them, and I told them to copy the prompt into their LLM of their choice. And basically it was asking them to have a conversation with the LLM, mimicking a statistical consulting conversation. So the LLM was the biologist or the whatever, and they were the statisticians, and they were supposed to have a conversation to understand what the LLM's research problem was and such. And it was fascinating to see those. First of all, they had fun. They thought it was fun. So that's always good if they're having fun in your class. But I think my favorite question that they typed into the LLM was, how many degrees of freedom do you have in your experiment? Which I told them was not a good question, because your client from another discipline will not know how many degrees of freedom they have, nor is it their job to know that. That's your job to figure out as a statistician. So I was very happy to have that conversation with them in a safe, fun space in class so that they didn't go to our real client partners, collaborators, and ask that. So that was really, really, well, fun and sort of a safe and friendly way to have direct conversations with them about what was and wasn't appropriate. Or even asking them, what is your sample size? Like, that's not necessarily the most effective question, depending on who you're talking to. They may not know about independent observations or repeated measurements. You should ask those kinds of questions. And you, as a statistician, figure out what the sample size is afterwards. So I thought that was very effective. So there's no right or wrong answer there. It's using the conversational strengths of the tools to use it. So yeah, that's one way.
Thank you.
Any other questions? Okay, there's a couple. I'll start in the back first, and then I'll hand it over to Glenn after. Hi.
So I guess about the automated testing with your unit tests, I remember a long time ago in my computer science classes having unit tests for my programming assignments. And some of the times we would get our, like, write some code, plug it into the unit test. We got like finally many opportunities to test them. And if we didn't get something right, we said, why? Because we don't know what the unit tests are, right? So I guess for me, it was a lot of, because I wasn't the most amazing programmer like 12 years ago, I said, I don't know, just gonna tweak something and try again, right? So there was maybe not the most critical thinking about like, okay, how do I actually make my program pass the unit test? So I was wondering, like, what do you do specifically to make your unit tests like a little bit more
deeper.
Yeah, deeper, yeah. Or at least like encouraging students to think more critically about what it is that their code is missing.
Yes, absolutely. So that's a great question. And I'm not going to claim that what we're doing is perfect. I mean, of course, you can just guess your way through it. Typically in my courses, I've not set a limit, so they can do it as many times as they want. You can set how often the tokens refresh. So I give them like 6 tokens and they refresh after an hour, but you could do longer because you don't want people to just resubmit every 5 minutes. That's not the point. So first of all, with the way Marcus is set up, you can see the individual tests. So you can see which specific test failed. It's not just, I mean, you can set it up so that you just see the score. The way I use it, you can see each individual test, and each test has a name, like a unique name that refers to, so typically I name my things like, question 1A, number of columns. So you can tell which part of your code is wrong, but like is affected by that test. You can customize as well with Marcus whether the students can see any error messages associated with that particular test or not. So depending on the use case, you could do that or not. But I don't think we can fully prevent that. But I think, but for me, having it be the test uniquely named helps a lot. I mean, it helps for my own. Like I run the tests before I give them the assignment as well. So it makes it easier for me to debug as well.
Great. We have a question over here as well.
Yeah, I was just wondering if you had thought about at all or had any interest in going back to the Marcus system. The question isn't about Marcus in particular, but just if you thought about the possibilities or limitations of any software system that could provide feedback on the correctness of a proof. Maybe very structured, simple proofs that only have a few paths to being correct.
Right.
Have you ever thought about anything like that?
So I don't think unit tests per se are the way to go for that, unless there was like some check-in point. Like for unit tests, it's really looking at to simplify equality of various things. So that probably doesn't work for a proof. I know that one of my colleagues is working with the Marcus team to I don't know how exactly, but to integrate some AI feedback. If they're looking at it in the context, for example, of plots. So I have implemented unit tests to check various features of plots, like do you have the right variables on each axis? Is it the right kind of plot? If I ask for a box plot, do you give me a histogram? That's not good. but he's working on using AI to look at the output of a plot and give more qualitative feedback. I think there's work they're doing as well to turn sort of following up on the previous question, the unit tests are fine, but some students they're novice programmers. They don't maybe fully understand that. So to turn that output, like have the unit tests run in the background, but maybe then use AI to like output a more human-friendly version of that feedback to point them to what to do next. So perhaps things like that could integrate to work with proofs in a better way. Maybe, I'm not sure. So the nice thing working with Marcus is that the development team is very active. So they're very responsive to tweaking things, even on the fly, not to incorporate Gen AI, that's not an on the fly kind of thing, but they are actively using it in CS and across the university. I think the University of Waterloo is using it as well. And it's very much an active development process.
Calculus, linear algebra courses are actually very large too.
Yes, they are. I mean, there are other platforms like WebWorks, I think is one. I don't know if you use WebWorks here. U of T doesn't support it with our, I looked into it, but we don't, you can maybe use it with other languages. But it also does, or it can generate like questions from problem banks with randomness. And so on. So Marcus is a little bit different. Marcus can work with randomness as well. I didn't talk about that here, but you can have, for example, students input their student number and then use that as the random seed so that each student has like a uniquely different data. And Marcus will grade according to their like unique student number.
Okay, and I think we're about out of time. We do have a response on the screen as well that's saying that for proofs, there are some software tools that validate. I've heard of Lean and COQ. I don't know what that is, but that's something to look into too. Thank you for coming, everyone.